Okay, so testing in general, there are something called very basically called unit testing. Now the unit testing is a bit ambiguous because the unit is kind of subjective, right? You can consider unit as a for loop. You can consider unit a function. You can consider unit just a package, a software package. You can. So if you have like on your smartphone, you have all those apps, all those features. You can testing every feature, but putting all together doesn't mean they're going to have a functional phone, right? So you have the unit testing, and then you need to integrate them. Once you integrate, there'll probably other issues, and then you need to fix one unit. You fix one unit, it probably affect another unit. So this testing, although unit testing is probably one of the basic steps, you need to the so-called regressive regression testing. Basically, it's basically agile process, right? So you do the unit testing, integrate, go back, and so unfortunately, I haven't heard any software without a bug. Or I haven't written, even myself, I have not written any software which is perfect. So I seriously doubt there's any perfect software exists in this world. So, okay. So generally, testing, there are several ways. Black box testing or glass box testing. Let's say before I move on to go to the lecture, let's do, for curiosity, let me do a few, wait a minute, that's not it. Okay, let me do a survey just to see, just have some fun, okay, a little fun during the lecture. This is just a curiosity. Have you heard of Grace Hopper? Wow, this is amazing. Okay. Gee, wow. Okay. I'm actually quite surprised. I thought many of you would have heard of it. Apparently not. Okay. Okay. Based on your experience, what are the effective ways to identify bugs in your software? So. Very good. Printing using a debugger, a textile process steps. Okay. That's a very advanced version. Yeah. Printing, debugging tool. Yeah, printing is just most straightforward way. It works almost every system. Debugging tool usually has to be platform and language dependent. So, but having a debugging tool, know how to use it, certainly is also very helpful. So. Okay. Oh, that's good enough. Okay, let's move to the next question. So. What's the general ways to prevent the bugs in your software? Because bugs have very they are logical bugs, they are typing, they are auto bugs, they're all so I guess this is not a very, there's no one silver bullet to solve everything, or magic bullet. So now testing, well, testing is a way, but how do you prevent? But you need to have something called a defensive programming, basically good habit. There are something like, for example, if you change a looping variable inside a loop, that's just not a good practice, right? Even though the new version of Python actually automatically fixes that error, but it just shows you shouldn't do that, right? So, which means if you change a looping variable, Python basically negated it, so you don't even know what happened, right? So you basically need to have something called a defensive programming, anticipate what could be the common problem, right? So for example, if you write a while loop, you need to make sure it's not going to infinite loop, right? So, and there will be like, if it's a division, try to make sure there's no division by 0. If you are accessing an element in an array, trying to not go out of bound. And so there's a lot of good practice for defensive programming ways to prevent the bugs from happening in the first place. Okay, so of course testing, but testing is kind of afterwards, right? So testing is not prevent bugs from happening. Okay, so once you found the bug, what's the typical way to fix the bugs? And based on your own experience, when you identify a bug, what common way we can to fix the bug? This is, of course, it's also quite broad. Yeah, so like the Boeing airplane, take how many? 1.5 years to fix that problem. So yeah, and there are some issues in Google's the search engine. After 2 or 3 years, they still haven't been able to fix it. So. Cut and paste usually it's not a good idea in coding exercise. I would say many of problem is because of cut and pasting. So, but that it's not easy. One solution will prevent that bug. It also depends on the actual bug. If it's just typo, I mean, you fix the typo. If it's the out of bound, you put assertion. Make sure before you access indexing the object or list or dictionary, whatever you are indexing or accessing is not out of bound. So but there are some errors that are very hard to fix, especially design problem or logical problems. In those cases, you probably had to just rewrite the code completely, or even go back to the drawing board, try to redesign how the software should work. So it's not uncommon for a large company just throw away the entire code and rewrite everything from scratch for that reason. So there are sometimes the bugs or issue in the software come actually from the design issues. So it's actually not a coding or code. It's not because the code is completely because of design issues. So it's like when you build a house, you build a foundation that way. Later on, it's hard to change. Sometimes you have to raise it and build it from scratch again. So, okay, I think it's a good way to get the start on the testing. So it looks like many of you have many experience of various ways to do the testing, but in general, philosophically, we can have two kinds of testing. One is called black box testing. Another is called glass box testing. The black box testing, basically, I mean, it's just as the word say, we treat a function of software as a black box. This is generally the case when you have a new app on your phone and you want to use it. You don't really look at how the app are rated, right? You just try a different way to see whether it's working. That's basically is the black box testing. So the I mean, literally, this is just treating the software, a function, or a block of code as a black box, meaning we are not looking inside. We are just give it the input and see what's the output. That's called black box testing. The glass box testing, on the other hand, is something is we look at the code, then decide how to testing. And in theory, we are also trying to testing every possible situation. Can make sure every line of the code are wrong, and every combination of the code, every combination of the branches are wrong. So it's so-called a path complete testing. So in theory, although very rare, you can actually do that in practice. So okay, so let's first start with the black box testing. So okay, I'm recording this. So this is the example. We have this code called calculate the square root of x, and then we have the epsilon, which is the precision, error tolerance. You can consider that. It's actually very similar to the fixed minimum monthly fixed payment for your credit card problem in a coding assignment. So that's this epsilon, you can just consider that the precision. And then we have the debugging flag. So we are going to just treat this as a black box. But how do we do that? We are going to put the testing different boundaries. We are going to put, say, 0, 25, less than 1, 2, and then we also try some extreme values like 2. Well, this is the extremely small precision. 1 divided by 2 to the 64th power. So that's an extremely small epsilon. So, let me run the code. Okay, so I start with what? Let's see. One is that, am I still starting with 1? Let's see. 0, sorry. Let's start with 0 first. 0 square root is 0, it works. And next one we start 25. Well, 4.99, it's good enough. Very close to 5. Okay, but you can also see this is numerically, it's not exactly 5. So although it's accurate, it's only to 1, 2, 3, 4, 5 to the 10 to the minus 6 precision. Oh, actually, that's correct. What's the precision? 1, 2, 3, 4, 5. Actually, that's actually good. Very good. It's actually more than I specified. So what's the next one? 25.05. This actually is not working. So this is actually go to infinite loop. So, oh, stop. I had to break this. So, wait, interrupt. Here, sorry, interrupt. So, there. So this code. Oh wow, it's actually run really a long time. So let me scroll back. Okay, can I just clear this? No, can I clear the output? Clear output. Okay, yeah, so what this means, this code does not work for less than 1. Let's try 2. So in fact, there is a reason why it doesn't work. If you look at the code, you will know. It's actually because of this line. When the square root is less than 1, that logical is incorrect actually. So, but obviously, if you look at that code, it's not black box texting anymore, right? So, but I'm telling you the reason here. So, but if we just without looking at the reason, let's try 2. So, 2 is correct. All right. So basically, you can't go away. Basically, this will be the black box testing. And we are not even trying to fix it. We are just saying, well, it doesn't work for less than 1. Obviously, if it's minus, it shouldn't even work, right? So because the code, obviously minus is no square root unless you use a complex number, right? So there's no real square root. So let me clear the output again. So, this is actually not in the slides here, but the issue is here. This code we give you, but in reality, this square root only works for something greater than 1 because of the way the code are written. But using black box testing, you can see whether it works or not. So this is one example of black box testing. And the next example is trying to show you what exactly is the glassbox testing. Right? The glassbox is something we are looking everything clearly inside. Right? So what we are trying to do, look at every code, every branch, every loop. We try to do the so-called path complete, all the possible ways this code can run in theory. So, but for simple code, it's possible, right? For like some other code, like a cell phone, Microsoft Windows, or even something like what other things like Boeing airplane auto drive, right? So it's really hard to do the so-called path complete testing. But if you really the advantage of the glassbox testing versus black box testing is at least we try to do the path complete, trying to figure out a way whether this is working or not, right? So the black box testing seems to be sometimes does not meet the security, even the quality requirement. So even though it's very simple. So okay, so in this example, we have what? It's just a very simple function. Take the ABS with the input. If that is less than -1, we return. Else we return not. So if you think about this, I mean, this is certainly not correct. The whole point of this is to show you there's a bug in the code, right? So if we test it -1, it's correct. If we test -0.5, you can see in this case -0.5 because it didn't go through this branch, it return the bottom one. So this becomes a wrong answer, right? So if you really want to fix this, you have to go back, fix this logical. So I think if that should be less than 0, actually should be correct, right? So I'm assuming this is a real number, not a complex number again. So yeah. Okay. So this is the glassbox testing, and recall I asked you who is the grasshopper and who actually gave the name of the bugs. She is actually the first person called this a bug. That's the kind of computer she was working on. They are all the board. And one day there's actually a bug, a mouse fly into one of those circuit board. And of course, once the bug was fried, literally died there, but it also shortened the circuit. So and of course, the relay, it looks like it's a relay number 30 panel mouthing relay. so it is a real bug. It actually saw the first actual case of bug being found. And that's apparently that term, even though nowadays very rare we see a mouse flying into our computer, but we're still using bug to describe the problem we have in the software. So, and next time when you say you want to fix bug, you should know Grasshopper is I think that's probably Grasshopper's notes. Yeah. And in general, if we want to fix bugs, there are several kinds. And overt, the so-called obvious and the persistent bug. Those are the easiest bugs. There's things like a typo, there's things like typo, what else? Like wrong operation, wrong function, like if you want to use an integer, but you use a floating point. Basically, something is terribly wrong. Those are something we call obvious and repeatable mistake. Those are the easiest one we can fix. And then there are those, oh, sorry, I have a typo here, overt but intermittent. Basically means it can happen, but doesn't always happen. You need to have some condition to trigger that bug to occur. This is a bit troubling because we are not always know what condition caused that bug. And this is actually one of the major issues for many consumer-based software. Actually, not just consumer, I mean, obviously for Boeing, that's also an issue there. So it's the intermittent bug will be really hard to fix. You need to find out the condition, how that bug is triggered. And then there are also the most difficult one, the so-called covert and hidden errors. Basically, we don't even know the bugs are there. And we know, generally, probably no software are perfect. And so the software, as our programmer, software developer, we know there are potential bugs. In fact, if you look at every software release, they always say, if you look at the acknowledgement of every software release, you never say any statement will guarantee the output is correct. There's no such a thing in any software product as far as I am aware. There's no software release actually guarantee the result is correct. It's always say, we provide the result as it is. It's your responsibility to make sure the result is correct. Which is really funny if you think about this has generally been true in software industry. I'm not a training in legal affairs. Someone go to law school may study this in much detail. So yeah. So in fact, if you look at Windows, your phone, you always say, we provide this, the result is provided as is something like that. Yeah. So basically, because when we write software, we know we are not going to cover everything. And there are many errors the user probably even unaware of it. And in fact, I even heard a story in some large national research center. They had to keep a computer, very outdated computer there, because there are some procedure they have to using that very old computer to run to reproduce it. But they know that is wrong because many things depend on it. So they don't know how to fix it. But that very old computer are kept there for a long time simply because it runs something even though it's wrong, but many other things depend on it. So unfortunately, yeah. So in that case, it's not even covered. They just know it's wrong, but they don't know what's going on there. So yeah. Okay. So now let's we have talked the talk. We need to walk the walk, I guess. So on the canvas there is a student version of IPython notebook. So if you if you click that, it should download a copy of it. Let me see. And then there should be a palindrome problem, the so-called palindrome words or working problem. And oh, I see someone had a chat again. Palindrome word, a palindrome word, words. A palindrome word, basically you read left to right, right to left, they are the same. For example, here, palindrome words. Those are madam. Oh, madam is a palindrome. Yes, the madam is a palindrome one. MADAM. So left to right, right left is kayak. Oh, I didn't know kayak is also one. Kayak. Reader. Okay, civic. Oh, gee. Those are. I'm quite surprised. There are so many words about palindrome. Redivide. Oh, this is hard one. Yeah. So basically, that's the palindrome. So left and right, right and left, those are palindrome words. So, and this is the code supposed to identify the palindrome words. And the top one is the code to decide the palindrome. The bottom one is just the auxiliary function to help it run. So, and we can testing this by testing a palindrome, say ABC, or just say silly number of character. So okay, it looks like no one joined the breakout room. Okay. Okay, so let's first look at the palindrome. Palindrome will be ABA, that will be a palindrome, right? So let's see. Oops. True, it says ABA is correct. Right. So, but what if we change this to ABC? Well, it also says true. So obviously there's a bug in the code, right? So what does the silly do? Silly actually is the interactive way. So silly 2 will be A, B. As A and B is correct, it's also wrong. It shouldn't be. If we put a silly 3, A, B, C, it's also true. It's just like A, B, C. So but something is wrong. And the way to debug it, remember, is just print. So I just put a lot of print in this trying to see what's going on here. So I rewrite the code, just add a lot of print, right? Before the reverse, after reverse, just to see what's going on here. And let's put what? A, B there. So it looks like there I have A and B. So, okay, before reverse is A and B, after reverse X is B and A, but the temp is also B and A. So that's why we got a yes, even though it is shouldn't be, because both and temp are reversed at the same time. What it means is input X, temp is X, and temp are the reverse, and temp and X also are the same. So of course it's, oh, wait, here. So because X and Y are both reverse, so of course they are the same and return true. And the way to fix this, someone say we can copy it. We just make a copy of it. That's it. So that's how we fix this. So now if I say silly, A, B, C, now it returns false. No, it's not a palindrome. So that's there. That is a fix. Right? So it's good. Let me come back to the survey. No, that is not a question. We should be reversing. No. Yeah, it looks like this is the only correct answer. So